Okay, so now let's do our part 2. It's still the limit as x goes to 1 of x squared plus x minus 2 all over x squared minus 1. So remember, we'll say let f of x be equal to x squared plus x minus 2 all over x squared minus 1. And this is beautiful because when we are plotting, when we're sketching, the first thing we look for is end behavior. And here we can see horizontal asymptote. So what is going to be the horizontal? I see the power on the top, the highest power is the same as the highest power on the bottom, which is beautiful. Both of them, the highest power is 2. So what am I going to do? There's going to be a horizontal asymptote here. And for my horizontal asymptote, when the powers are the same, you take the number before, which is before the highest power on the top, divided by the number which is before the highest power on the bottom. And you can say horizontal asymptote. Here it is at the line y equal to 1 over 1. Okay, we take, what is the number here? 1 divided by the number here, 1. So we can say, therefore, horizontal asymptote, the horizontal asymptote is the line y equal to 1. Okay, is the line y equal to 1. There we go. Now we have a horizontal asymptote as the line y equal to 1. We go ahead. What do we have? F of x being equal to this. So we can still put to say f of x is going to be equal to x squared plus x minus 2 all over x squared minus 1. We factorize like we did. When we factorized, what did we have? What were the two things we had? It was x plus 2x minus 1, is it? So that it cancels. It was, let me go up. Yes, it was x plus 2x minus 1, okay, for the top. All right, so here we have it as x, the top is x plus 2, x minus 1, okay, x minus 1. Then the bottom is x plus 1, x minus 1, okay. This one, because it's difference of two squares. And x minus 1 and x minus 1 cancel, will remain with our f of x being equal to x plus 2 over x plus 1, okay. Now, already we can say that you say let the one which has just been cancelled, which is x minus 1, say let x minus 1 be equal to 0. You get x equal to 1, right? When it goes there. So you can now say f of 1 is going to be equal to, in here, we say 1 plus 2 over 1 plus 1, which is going to be 1 plus 2 is going to be 3 over 2. And you get it as 1.5. So you can say, therefore, there is a hole at, what is the x value? 1, comma, what is the y value? 1.5. And this is where we have our limit. We're already seeing it at this hole, but we are not yet done. Let's finish it. Let's now put f of x is going to be equal to, we still have this, x plus 2 over x plus 1. So x plus 2 over x plus 1. Now you're going to say let, you can say for vertical asymptote, you can say for vertical asymptote, now. After cancelling, we remain with this. So for vertical asymptote, you can now say let x plus 1 equal to 0, which means that x equal to negative 1. You can say, therefore, there is a vertical asymptote, at the line x equal to negative 1. X equal to negative 1. So we have all this now. Look at this. We have all this, huh? We have the whole, we have the horizontal asymptote, we have the vertical asymptote. Let's do the intercept. So we can now say f of x, we use the simplified version, of course, for intercept, x plus 2 over x plus 1 is equal to x plus 2 over x plus 1. And you can now say for y-intercept, we say let x equal to 0, okay? So we can now say f of 0, where there is x, we are now putting 0. F of 0 is equal to 0 plus 2 over 0 plus 1, which is 0 plus 2 is 2, over 0 plus 1 is 1. 2 over 1 is just going to be 2. So you can now say, therefore, y-intercept is at, what is the x value? 0 on the x, and y, 2 is at 0, 2. Okay, then you can put f of x again here to say f of x is equal to, we had it as what? X plus 2 over x plus 1. So x plus 2 over x plus 1. And we can now say for x-intercept. So we now say for x-intercept you let y be 0, okay? And y here is just f of x. F of x is another word of y. It's the other way of writing y. So you say let f of x equal to 0. That means where there is f of x, we are putting 0. So 0 is equal to x plus 2 over x plus 1. And we know that when a fraction is equal to 0, it means the top is 0. So you can just say x plus 2 is equal to 0, which means that x equal to negative 2. So we have our x-intercept. So therefore, you can say x-intercept is at, what is the x? Negative 2. What is the y? 0, okay? X is negative 2, y is 0. Remember, intercepts are coordinates. Asymptotes are lines. So don't forget that. So that is why I did it. Now, what is the last thing? I have to now just put, okay, so this is done. And now we are going to sketch. So the one we're going to sketch is this one. But just remember that we should not leave the hole. So when we're sketching this is actually a rational function. So when we sketch this, right, I'm going to have, remember, f of x now being that simplified version, which is x plus 2 over x plus 1, okay? It is equal to x plus 2 over x plus 1. Now, the last thing which I need to do, this is actually a rational function which you're trying to sketch, my friend, which means that it is going to have that shape probably like this, you know? So what we are going to do, we are going to have to prove what it is like, right? And basically what we do is we go to the position, we have to go to the position where we had our vertical asymptote. We have to go to the position where we had our vertical asymptote. So where is my vertical asymptote? Where is it? Vertical asymptote is at x equal to negative 1. So I'm going to come at my number line with a pencil. This is you with a pencil. And you can have your negative 1 here. Okay? So now what you're going to do is you are going to choose two values that are just before and just after your vertical asymptote. Because what we know is that when I'm getting towards my vertical asymptote, either I'm now going to negative infinity, which means I'll be like this, or I'll be going to positive infinity like that. You get it? Let's say this is my vertical. So close to your vertical asymptote, you'll be high up, my friend. You'll be going towards either positive infinity or negative infinity. We know that when you're close to the vertical asymptote itself, you'll be either very high up in positive infinity or very high up in negative. So we're going to see them both. We know our vertical asymptote is at negative 1. So what is the value which comes just here? This is going to be, if I have, this is 0, and this will be negative 2. So just after here, this will be negative 1.001. Then here, just before, this is going to be here, negative 0.999. That is just before negative 1. Then here, just after, is negative 1.001. So I'm going to put these two values and I see, are they going to give me negative infinity or positive infinity? I'm just going to see. So I'm going to say f of negative 1.001 is going to be negative 1.001 plus 2 all over negative 1.001 plus 1. And what I'm caring about is the sign. So here, what is 2 minus 1.001? The answer is going to be positive. You can say this is going, if you want, you can do the solution 0.999 over here. 1 minus 1.0, it's negative 0.001. So this becomes a positive over a negative, and our answer is negative. So that means this is going to go towards negative infinity. So that means this side here, just before negative 1, it is going down towards negative infinity. Now let's see on this side if it's going up or it's also going down. They can both go down. You know, now we're going to do f of negative 0.999. Okay, so 0.999. This is going to be equal to, here we say on top, if we are putting in here negative 0.999 plus 2 over negative 0.999 plus 1. Okay, then here what do we get? This is going to be 1.001, and over here this is going to be 0.001. That is what happens. These are the two, and it's going to be positive over positive, which gives us a positive sign, and therefore it means it goes towards positive infinity. Okay, you can say it goes towards positive infinity. This means it goes towards negative infinity. So we can now say, we can now put our graph. we have our graph like this. So this is going towards positive infinity. That is on the right side of your negative 1. On the left is going down. So that means it's like you can put the thing, you have it like this, you have it like a negative 1. Here it is going positive infinity. Here we saw it is going down to negative. So let's go ahead and let's put it. We have our negative 1. Our asymptote is at negative 1. Let's put the asymptote. So let's put it. We have a vertical asymptote at x equal to negative 1. And we have a hole at 1.1, 5. So here we have a vertical asymptote at negative 1. We can put our vertical asymptote. This is our vertical asymptote at negative 1. Here is our vertical asymptote, right? At negative 1, here is our vertical asymptote. Then we have our horizontal asymptote. Where is our horizontal asymptote? We found one. I know we had one. Horizontal asymptote is the line y equal to 1. So we go to y equal to 1 and then 1 and 1,5. So here we have y equal to 1, which is just like here. You can put it. We have a horizontal asymptote. So we have a horizontal asymptote here like this. Okay, we have a horizontal asymptote. Now, what else do we have? We are going to have at 1 in the x, 1 in the x, and 1,5. So, which is just after 1. Just after 1 here at 1,5. There is going to be a hole. So there is a hole here. And now, what else do we have? So I have it like this. And the last thing which I had is my intercept. So this is the line y equal to 1. This is the line x equal to negative 1. And here we have it at 1 and 1,5. So it's 1 in the x, and in here is 1,5 in the y. You can put it. Make sure you put it so that we can see. Now, the last thing you're going to do is give us the intercepts, please. So what are the intercepts? The x-intercept is negative 2, 0, and the y-intercept is 0, 2. So the x-intercept is negative 2, which is here, 0. Then the y-intercept is 0, 2, which is here. So it's like a 2. Okay? So now let's put the two graphs. So what are the two graphs? Well, here I know that it is going towards positive infinity. That means on this side. So it's coming like this. This is a hole. So it comes like this. Here is an asymptote. It's a horizontal asymptote. So it will never pass this dashed line here. Okay, so it is going to come close, but it will never pass it. Then it will curve up like this, passing through this point, curving, and never touching this other asymptote here like this. Then on the other side, it doesn't touch again this asymptote, and it curves down, passing through this intercept, and it doesn't touch the other asymptote as it goes towards negative infinity like that. And here it is like this, something like that. So here we have our asymptotes, and this is the line, like we said, y equal to 1, which is never touched again by your graph. This is going to be your graph, and it goes down like this to negative infinity. Then the other part is this one, which goes up to positive infinity, but jumps this hole. There is a hole that it must jump. And here you have your graph. Oh my, this is very beautiful. So we've done the graph, and we have seen that at this point, at the y value of 1.5, that is where we have our hole, and that is where we talk about our limit. So we are approaching this 1.5, the value of y, but we are never going to attain it. We are going to jump it when we put that. So we can say, therefore, since there is a hole at 1, 1.5, we have seen that we are approaching it from both sides. We'll be approaching the y value of 1.5. You can just say the limit as x approaches 1. We are looking at, as we are approaching the value of 1, that is what we care about. Look, when we are approaching the value of 1, what y value are we approaching? That is what we are proving with the graph. What y value are we approaching? And we have seen that we are approaching the y value of 1.5. That's the limit. So as x approaches 1, what y value are we approaching? That's just what we are asking. Plus x minus 2 all over x squared minus 1. This is going to be equal to 1.5. You don't even have to put since there is a hole. You can just say, as I am approaching 1 on the x, I will be approaching a y value of 1.5. And this is the reason. The reason is we are approaching y value of 1.5 when we are approaching the x value of 1. And you would be done. This is the final solution for this. And you're done, all right? That is it. Goodbye for now. We'll meet in the next video.